Welcome back. Today we're going to be talking about interpreting and analyzing graphs. We're going to be taking a look at all different kinds of graphs and trying to answer questions and glean predictions from them. Let's get started right now. So let's take a look at example A. In example A, Lucy and Ava kept track to how many hours they spent on homework over the last 5 days. Using the information in this graph, circle all of the statements that are true. So we're going to go through, we're going to answer each of the questions. We're going to determine which ones are true and which ones are not true based on this graph. So let's start with letter A. Letter A says, over these 5 days, Ava spent more total time on homework than Lucy. So all we're going to do is we're going to add up each of their amounts, and whichever one has more, we'll be able to know our answer. So let's start with Lucy. So we're going to add 2 plus 3.5 plus 4 plus 1 plus 2.5, and that gives us 13 hours of total homework. Now we're going to start with Ava, and again we're going to add up 1 plus 1 plus 3 plus 3.5 plus 5, and we get 13.5. So 13.5 is more than 13, so did Ava spend more total time on homework than Lucy? Yes, so this statement is true. Letter B says, Lucy spent the same amount of time doing homework on day 1 and day 2 as Ava spent on day 3 and day 4. So again, let's take Lucy first. We're going to add up her day 1 and day 2. So 2 plus 3.5 equals 5.5. Now we're going to take Ava's day 3 and day 4, and when we do that, we get 3 plus 3.5, and we get 6.5. Well, 5.5 is not more than 6.5, so therefore this statement is not true. Now let's take a look at letter C. The mean number of hours that Ava worked in day 3 and day 5 is 3.5. So we need to find the mean. In order to find the mean, we need to add the numbers up and then divide by the total number that there are. That will give us the average. Since this time we're only going to be adding day 3 and day 5, we're going to be dividing by 2. So let's add up day 3 and day 5. So that's 4 plus 2.5. That gives us 6.5. We're going to divide 6.5 by 2. And when we do that, we get 3.25. And 3.25 is not 3.5. So therefore, this statement is not true. The last one says the median number of hours that Lucy worked is 2.5. So remember, when we're finding median, we're finding the number in the middle. So in order to find the number in the middle, we need to line them up in order from least to greatest. So let's do that. I've got 1, 2, 2.5, 3.5, and 4. So now I'm going to just put an X over each number on the outside. We're going to work our way towards the middle. So I'm going to X off the 2 and X off the 3.5, and the number in the middle is 2.5, and that is what we are looking for. So that statement is correct. So we've got 2 right answers, 2 wrong answers, or 2 true statements and 2 not true statements. Let's go ahead and take a look at example B. Here we are at example B, and it says Jason is the manager at a convenience store. He made this graph about the number of hour employees he has on staff. This graph will be important to Jason, though that he knows how much he's paying his staff, who needs to be promoted, who maybe needs to be demoted, make sure that he's keeping track of expenses. So let's take a look at the questions that he wants to answer. So the first question says, how many hourly employees work at Jason's store? So we're going to need to add up the total number of employees that are there. So for the $8 an hour employees, we have 10, and then we have 8, then we have 6, and then we have 5 and 6. So we're going to add those all together. So 10 plus 8 plus 6 plus 5 plus 6, and that's going to give us a total of 35 employees. The next question says, what is the mean average wage of the employee? So we have to figure out what is the average wage of an employee at Jason's store who works there hourly. Now, I can't just add 8 plus 9 plus 10 plus 11 plus 12, because that would only be 5 employees, and we just figured out that there are 35 employees. So I have to figure out how much each column makes as a total amount of money, and then add it up and divide by the total number of employees, which we just figured out was 35. So I'm going to start by writing little numbers above each column so that I can track how much each column makes. So 8 times n is 80. 9 times 8 is 72, 6 times 10 is 60, 11 times 5 is 55, and 6 times 12 is 72. So I wrote down a little label above each of my columns so that I knew how much money each column made. So then I'm going to add those columns together, 80 plus 72 plus 60 plus 55 plus 72 equals 339, but they don't make an average of $339. I need to divide that by the total number of employees, which again is not 5. Just because we have 5 columns doesn't mean there's 5 employees. There are 35 employees. So when I divide 339 divided by 35, an average salary is $9.66. And if you take a look at the graph, that makes sense. There's about 18 people who make between 8 and 9, and then the numbers are smaller for 10, the 11, and 12. So between there, you're going to find the $9.66. So the last question says, which percentage of employees make less than $10 per hour? So we're going to figure out the total number of employees that make less than $10 an hour. So I can't add the 10 column because they make $10 per hour. So it can only be the columns of the $8 an hour employees and the $9 an hour employees. So when I do that, I talk about adding the 10 people in the $8 column and then 8 people in the $9 column, and I'm going to get 18 people. Now, I have to figure out what percentage that is, so I'm going to figure out what that is out of the total. And since I know the total number of employees is 35, I know that 18 divided by 35 employees is going to give me 0.514, and I'm going to turn that decimal to a percent by moving my decimal 2 places to the right or multiplying by 100. And when I do that, my new percentage is 51.4% of employees making between $8 and $9 an hour. All right, let's take a look at example C. So here we are at example C. It says Elias made a histogram displaying the data about the number of text messages he sent in February. Circle all the statements that are true. So let's take a look at letter A, and it says on exactly 2/7 of the day in February, Elias sent between 76 and 100 text messages. So taking a look at the column that has 76 to 100 text messages, that number of days is 8. So what we need to determine is 8 2/7 of February. So I'm going to take 2/7 times 28, because there are 28 days in February. We're assuming no leap year here. And when you do 2/7 times 28, we get 8 days, and that is exactly where the 8 is in the column, so that statement is true. Let's take a look at letter B. On letter B, it says, on more than half of the days in February, Elias sent between 51 and 100 text messages. So here we're going to have to take a look at 2 columns, because not just one column is between 51 and 100. We're going to need to use the 2 columns in the middle that span from 51 to 75 and 76 to 100. We're going to combine those 2 columns, and when we do that, we get 5 plus 8 is going to give me 13. Now, is 13 more than half of the days in February? Well, half of the days in February, if there are 28 days in February, divide 28 by 2, and I get 14. So 13 is not more than half because it isn't even half. So that statement is not true. Looking at letter C, for exactly 1/4 of the days in February, Elias sent fewer than 26 messages or more than 125 messages. So I have to determine that there are 1 out of the 25, less than 26 text messages would be the column from 1 to 25, and that's 3 days. And then the column that's 126 to 150, because that would be more than 125, there are 4 days. So I'm going to add 3 plus 4, that is 7. And I have to determine if that is 1/4 of the days in February. So I'm going to take 28 days in February, divide by 4, because that will break it up into quarters. And when I do that, I get 28 divided by 4 is equal to 7, and that is the number that he got. So this statement is also true. The final letter says on exactly 6 days, Elias sent 50 or fewer text messages. So if he spent exactly 6 days, Elias sent 50 or fewer text messages, I need to look at the column, and it says 50 to 26 would be 6 days, but that is not the only column I need to look at, because on the days where he sent 1 to 25, that would also be less than 50 text messages. So when I add those 2 columns together, 6 plus 3 is equal to 9 days, and then that is not exactly 6 days, because I had to include both columns. So that statement is not true. All right, let's go ahead and move on to the next one. Here we are at example D, and it says Mr. Smith took his class to the library to check out books for the summer reading. The librarian made this line plot to represent the number of books students borrow. Each X represents 1 student in the class. I want you to try and answer these 4 questions on your own. Go ahead and pause the video now, try and do the 4 problems by yourself, then press play again to see if you are right. Okay, how did you do? Were you able to get all of the answers correct? Just a few things to go over before we move on. First thing we want to talk about is how many students there are in the class. To do that, we added the x's. To figure out the mean, we needed to take the total number of books. So notice I wrote the little numbers above all of the x's so I could figure out how many books were in each column. And then you divide that by the total number of students, which in this case was 20. We figured that out in A. We got that. We figured out it was 2.55 books. To figure out the median, we needed to line them up in order from least to greatest, which I did, and then X off until you got to the middle. We found out there were 2 books. And then to figure out the percentage of who borrowed more than 3 books, remember that we can't count the column that has 3 books in it because that's not more than 3. So we can only add the 4, 5, and 6 book students. We do that, there are 6 of those. And then we take that out of 35, we got 0.7, which we turned to 17%. Let's go ahead and take a look now at the last one. Here we are at the last one. This is example E, and it says this stem and leaf plot shows the scores from the latest math quiz. Circle all the statements that are true. So we're trying to find the statements that are true and the statements that are not true. So let's take a look at the first one. It says the mean quiz score is greater than the median score. So to figure this out, I'm going to have to find both the mean and the median and determine which one is greater. So let's start with the mean. So I'm going to add up all of my numbers, and then I'm going to divide by however many numbers there are. That's how I find the mean. So when I'm using a stem and leaf plot, I remember that the first number refers to the lead, and the second leaf refers to the ones column. So for example, 42, or 68, and 68, and 72, 80, so on and so forth. So I'm going to add up all of my numbers. When I do that, I'm going to get 803. There are 10 test scores, so I'm going to divide 803 by 10. I'm going to get 80.3. So that is my average, that is my mean. However, I still need to find the median in order to determine if the answer to this question is correct. So to find the median, I have to write my numbers in order. So let's go ahead and do that now. Then again, I'm going to cross off from the outsides until I've got one left in the middle. You could do this in your stem and leaf plot if you'd like, or you can do it by writing them out. We wrote them out, but it doesn't mean that you couldn't do it with the stem and leaf plot. Now, when I do this, I end up with 2 numbers in the middle, and since those 2 numbers are not the same, I'm going to add them together and divide by 2 to figure out their average so that I can figure out if they are correct. So let's go ahead and do that. I'm going to add the 80 and 85 together and get 165. Divide that by 2. When I do that, I get 82.5. So, is the mean greater than the median? Well, 80.3 is not greater than 82.5, so the median is greater, and therefore this is not true. So let's go on to letter B here. Letter B says over half of the class scored 80% or better on the quiz. So let's see how many scores are at 80% or higher. We've got an 80, an 85, a 94, a 96, a 98, and a 100. So that is 6 scores. Now, since we know there are 10 scores total, is 6 more than half of 10? Well, half of 10 would be 5. 6 is more than that. So this statement is true. Letter C says 1/3 of the class scored below 70% on the quiz. So looking at scores below 70%, I've got a 68, a 68, and a 42. So that's 3 scores. So let's see if that's a third. There are 10 scores total, so I've got 3 out of 10, which is 0.3 or 30%. 30% is not a third because a third would be 33.3 repeating percent. So this statement is not true. Letter D says the same percentage of students scored below 70% as they scored above 95%. So let's see, we know 30% of the students scored below 70. We found that in our last problem. Then we need to figure out how many students scored above 95% on the quiz. We've got a 96, a 98, and a 100, so that's 3 scores. 3 out of 10 is equal to 0.3, or 30%. 30% does match 30%, so this statement is true. So that brings us to the end of this set of notes. If you like this set of notes, throw us a thumbs up. If you love this video, throw us a sub, and we'll see you in the next one.